في هذا الدرس سوف نتعرف على كيفية إنتاج أوراق الرسم Drawing Sheet. نقوم بإنتاج New Drawing Sheet. أوكي. نختار ورقة الرسم التي نريد إنتاجها A1 أبعادها 841 594 A2 594 420 A3 420 297 A4 210 297. نقوم باستخدام الورقة الأولى وهي 841 594. أوكي. نقوم بعمل براوز على المجسم الذي نريد عمل drawing sheet له، وهو مثال drawing sheet في الإكزامبلز. نقوم بفتحه. الآن تظهر لنا عدة خيارات. الخيار الأول configuration. إذا كان هناك أكثر من configuration create multiple views. نختار المسقط الأمامي أو الجانبي، أحد المسقط الأيزومتريك مثلا، أو الدايمتريك، أو تريمتريك. ايزومتريك مثلا. نختار شكل الديسبلاي، شكل العرض، أو بهذا الشكل، أو بهذا الشكل، أو بيكون شيدد. نختار العرض hidden lines removed. أوكي. نختار المسقط الأمامي مثلا أو الجانبي، فيقوم بالتغيير عليه في ورقة الرسم. نقوم بوضعها في المكان المناسب. أوكي. الآن المسقط الجانبي والعلوي يتم إنتاجهم من هذا المسقط العلوي. هناك عدة خيارات أيضا، وهي خيارات السكيل مثلا، الدايمنشن، السكيل، use sheet scale أو use custom scale. في هذه ورقة الرسم السكيل هو 1:2، يمكنك التعديل عليه. dimension type projected true و 3D display. نختار المسقط الأمامي في هذا المكان. للأعلى يكون المسقط العلوي، والمسقط الجانبي، والمسقط الثلاثي. أوكي. الآن نقوم بترتيب الورقة. بهذا الشكل. السبب وضع عرضين ثلاثيين الأبعاد هو التالي: نريد عمل section view مثلا للمستوى العلوي، فيقوم بعمل section view. نقوم بعمل section view للمستوى الأمامي بهذا الشكل، وللمستوى الجانبي أيضا بهذا الشكل. السكشن فيو يقوم بقص المجسم إلى نصفين، أما الإليجند سكشن فيو فيقوم بقص المجسم إلى أرباع. فهذا إليجند سكشن فيو، أما هذا فسكشن فيو، وكلها مسمية بأسمائها. أوكي. الآن نختار الديتيل فيو. نستطيع عمل الديتيل فيو عن طريق رسم دائرة في المكان الذي نريد توضيحه. فمثلا نقوم بعمل ديتيل فيو في هذه الناحية، ونقوم بتكبيرها. ووضعها في أي مكان. نلاحظ تم تكبير هذا ديتيل فيو. نقوم بتحريكه. اوكي، ووضعه بمكان مناسب. الآن نستخدم البروكن اوت سيكشن. broken out section يتم على المساقط نفسها عن طريق رسم SB line في المكان الذي نريد توضيحه. فال SB line بيقوم يعني بفصل القشور الخارجية للجسم ويظهر ما في داخله إذا كان هناك تفاصيل يجب إظهارها. مثلا نقوم بعمل section view في هذه الناحية عن طريق SB line ويكون مغلق. اوكي، فأظهر لنا ما في داخل هذا الجسم عن طريق البروكن اوت سيكشن فيو. نقوم بعمل بروكن اوت سيكشن فيو في هذه الناحية عن طريق SB line أيضا. broken out section view. اوكي، إذن broken out section view يقوم بإظهار الملامح الداخلية للمجسمات. نقوم بعمل break view للمسقط الجانبي، وذلك عن طريق رسم select drawing view to break. selected view cannot be detailed view or cropped view. إذن يجب أن يكون مسقط. نختار شكل broken view للأعلى أو بشكل horizontal أو vertical. الجاب 10 ملم، ونختار straight cut أو curve cut أو زياج cut small zigzag cut. نختار straight cut أو curved cut. نختار الكيرفد cut ونضعها في المكان، فيقوم بعمل broken view. نختار الهوريزونتال وزجزاج cut فيقوم بعمل البروكن فيو. الآن نستخدم الكروب view. crops an existing view to show only a position of the view. عن طريق رسم دائرة. نرسم دائرة في البداية، نرسم دائرة في هذه الناحية، ومن قائمة drawing نختار crop view فيقوم فقط بإبقاء هذه الدائرة. هذا هو طريقة عمل drawing sheet. zoom to fit.
Drawings are used to document your 3D models in the traditional 2D format, including displaying dimensions and other instructions useful for manufacturing purposes. In SolidWorks, creating drawings is secondary to creating 3D models of parts or assemblies. What I mean is that you first create models in 3D, and then use the 3D data to generate the drawing. Even after the drawing is created, there's a direct association between the 3D model and the drawing. When changes are made to the model, each and every view in the drawing will reflect the change. This relationship between 3D model and 2D drawing makes the drawing process fast and accurate. Because of the mainstream adoption of 2D drawings in the mechanical industry, drawings are one of the 3 main file types you can create in SolidWorks. To begin a new drawing, you can use the File, New drop-down menu, or use the blank page icon. If you already have a part open, you can simply click on the Make Drawing from Part icon, or select it from the File drop-down menu. All 3 methods will bring you to the same interface to select the drawing template. This dialog box offers you a choice of sheet formats, including several standard sheet formats, as well as the option to use a custom sheet format. For this example, I'll select the standard A landscape format. This is the drawing interface. It's laid out similar to the part and assembly interfaces, with a working area, a feature manager tree, and a slightly different toolbar. The toolbar arrangement is slightly different here. Toolbars that were used in the part and assembly interface are now gone and replaced by two new ones, the Annotations toolbar and the View Layout toolbar. We'll take a look at the various commands on these toolbars later in this lesson. The feature manager tree is also arranged differently. Since we're no longer working in 3D, you don't see reference planes or an origin listed. Instead, you see the basic requirements for a 2D drawing, a sheet of paper listed as Sheet 1, and a sheet format. The sheet is the drawing area, and the sheet format is the title block that you see around the sheet. There are two distinct modes you can use when working on a drawing. You can be in Edit Sheet mode or in Edit Sheet format mode. The Edit Sheet mode is used to create drawing views and add details such as dimensions and notes. The Edit Sheet format mode is used to strictly modify the title block surrounding the drawing. Switching between the two modes is simple. By default, when starting a new drawing, you'll be in Edit Sheet mode. This is indicated here in the status bar. While you're in this mode, the title block will appear in a faint gray color. To switch to Edit Sheet format mode, right-click on the sheet format listing in the Feature Manager tree and select Edit Sheet Format. You'll see the appearance of the title block change. It now appears in blue and black lines as you're used to seeing in sketches, and the status bar now indicates Edit Sheet Format. You can now switch back to Edit Sheet mode by again right-clicking on the sheet in the Feature Manager tree and selecting Edit Sheet. As a shortcut, you can also switch back and forth by right-clicking on a blank area of the sheet in the graphics window and making your selection there. When you're working with a drawing that already has existing views, it will be very obvious when you switch modes. As soon as you switch to Edit Sheet format, all the views will disappear. This is only momentary, and it's meant to help you focus on just the title block when you make changes. When you're done, switch back to Edit Sheet mode, and the drawing views reappear. The specifications for drawings varies immensely from company to company and individual to individual. And for the remainder of the lesson, I won't be teaching you how to create one specific standard of drawing, but rather I'll teach you the tools and techniques required to create and detail drawings in general. This will allow you to produce your style of drawing, no matter how unique. Model view is a term used to describe any of the standard views available in a 3D part such as front, right, top, and isometric. Let's begin a new drawing. I'll click the new file icon. Specify a drawing template and select a sheet format. There are two ways of creating model views, either by activating the Model View command or by using the View palette. Let's begin by going over the first option. You can select the Model View command from either the Insert drop-down menu under Drawing View, Model, or by using the Model View icon on the Drawing toolbar. Now as I move my pointer into the working area, you can see there's a block next to my cursor. This block indicates that you're in the process of creating a view, and that you must now tell SolidWorks what part or assembly you intend to show in the view. Although we're working on a model view in this example, this block will show up whenever it's necessary for you to identify which 3D model you're referring to. Here in the Property Manager, you'll see a couple different ways to identify the 3D model that will be associated with this drawing. You can either select from a list of models which are currently open, or browse for other existing models. Once I select it, I'll click the Next button. The Property Manager now displays a message telling me how to proceed with this model view. I'll begin by adding a single view and specifying the view orientation that I want to have displayed for this view. Front in this case. Before I click on the sheet to place the view, I'll be sure to have the Auto Start Projected View option activated. And then click somewhere on the drawing sheet to locate the view. Since I had the Auto Start Projected View box activated, the Feature Manager automatically switches to Projected View mode. When you move the cursor away from the view you have just created, SolidWorks automatically projects the top, right side, and isometric views for you. Before we proceed, let me show you another way you can have SolidWorks create these views for you automatically. I'll click Undo to get rid of these views. And to begin inserting views again, I'll go to Insert, Drawing View, Model to get back into Model View Property Manager. I'll use the same part I did a moment ago, but this time, instead of using the single view with the Auto Start Projected Views option, this time I'll select Multiple Views. With this option, I can simply click on the icons that represent the standard views that I want to have shown. I'll click the icons for Front, Top, Right, and Isometric. And when I click OK, all of the views will be added. The front view is the main parent view of all of the other views. Now, if the parent view you created is not the orientation you had desired, you can click on the view, and then click on one of the other view icons to use that orientation for the view instead. As soon as I do, SolidWorks prompts me that this will update all of the other dependent views that are projected off of this main parent view. When I click Yes, all of the other views will be updated. Also, to move any of these views, you can click and drag a view by clicking anywhere on its border or any other model edge or vertex. You can also move views and other items in a drawing using the arrow keys on your keyboard. Just select the view and press the arrow keys to move it. As I mentioned earlier, there's actually another way to insert drawing views besides the Model View command we just went over, the View palette. Let me delete these views and we'll begin again with a clean sheet. To activate the View palette, click on the View palette icon found on the task pane. As with the Model View command, I can select from a list of open parts, or I can browse for a specific part. I'll go ahead and select from the list. Next, I simply drag and drop a view from the View palette into our drawing. Once the drawing view is placed, the Projected View command is automatically launched, allowing you to create the remaining views. Although the View palette does allow you to preview all possible orthographic views of a part or assembly, it's not possible to select multiple views in their View palette and drag them together onto the drawing. It's only possible to drag a single view and then use the Projected View command to add the additional views. Once you already have a view created in your drawing, a projected view is one of the simplest views to create. Simply activate the Projected View command from the View Layout toolbar. Once the command is active, all you have to do is select the view you wish to project from, and move the pointer in the direction you wish to have the view projected. Once the view is in the proper location, click and it will be created. With the projected view, the Property Manager gives us an option to display a view arrow along with a label if necessary. You can see in this isometric view that the part has a hole on this angled face. In order to display the hole properly in a drawing, an auxiliary view must be used. To create an auxiliary view, activate the Auxiliary View command from the icon in the View Layout toolbar. Once the command is active, click the angled edge of the model to establish the direction of the auxiliary view. And once again, just move the cursor to the desired location and click to locate the view. The view arrow can now be moved or stretched by clicking the arrows or the line and dragging them. It can also be hidden by unchecking this option in the Property Manager. One of the more common views used in 2D drawings is the section view. Creating a section view in SolidWorks is straightforward. Once a view is in place, I use the Section View icon here in the View Layout toolbar, or use the Section View command in the drop-down menu under Insert, Drawing View, Section. To create the section view, I simply need to draw a line indicating where I would like to section the drawing view. Now in this case, I would like to create a section view that cuts through the center of the circular part. However, notice as I move the cursor near the view, I'm not getting any feedback. At this point, if I draw the section line, there's no way to know if it's cutting through the center. There's actually one step I need to do before drawing the section. I need to wake up the drawing view's geometry to be used as a reference. In this case, if I hover my cursor for a second over the outer circle, notice the geometry is activated, and I see inference lines to the center of the circle. This process works for any other geometry as well in a drawing view. Simply hover over a line or point or any other geometry to wake it up and infer to it for aligning a section view. Now I just sketch a line through the view that I wish to section. Be sure the line extends completely through the part. As soon as the line is sketched, a preview of the section view will appear as you move the pointer. To complete the view, you simply click the left mouse button to drop it in place. Once the section view has been created, you can move it, but it will remain aligned to the view it was generated from, called its parent view. To find out how to break this alignment, see the section entitled View Alignment. There are several options in the Property Manager that will allow you to change the way the section view is displayed. These options become available upon selecting the view, so it becomes highlighted. You can flip the section view direction by clicking the Flip Direction checkbox. Change the label used for the view, the note font, and here you can select to display only the geometry that is cut, thus eliminating any edges that are visible in the background. To change the location of the section view, I can activate the Section Depth option. This displays a line parallel to the section line that I drew earlier. This new line determines where the section view is taken. However, the original section line will remain unchanged. I can change the depth of the line by using the spin box, or by dragging the line in the graphics window. Finally, if I had any edges in the view, I could use them as a reference for the section view depth. To see a preview of what the section view will look like, I simply click on the Preview button. Since I want my section view to be through the center of the part, I'll deselect the Section Depth option and click the green check to finish the section view. When creating a section view of an assembly, you'll find options available that did not come up when creating section views of individual parts. Creating the section view line is the same. You use the same section view icon and sketch a line through the assembly. The difference becomes apparent after completing the section line, at which point this dialog box will appear, the section scope. With the section scope, when creating a section view through an assembly, it's possible to exclude one or more components from the section cut. Here, for instance, I wish to cut through the base plate and the bracket, but not the swing arm. By clicking the swing arm, it's added to the list of components that will be excluded. Before I click OK, I'm also going to check the auto hatching option. This will cause the crosshatch lines of adjacent components to alternate direction, making it easy to tell them apart. Now I'll click OK, and click once more to locate the section view. As I zoom in, notice the swing arm has not been cut. Also notice how easy it is to tell components apart with the alternating crosshatch. If you need to change which components are cut, simply right-click on the section view and select Properties. The Section Scope tab is the same one we saw when the view was first created. I can add to the list of excluded components or take items away either by clicking on them again or by highlighting an item and pressing Delete on the keyboard. When a view contains small features that are difficult to see as standard drawing view, a detail view can be used to zoom in and make things clear. To create a detail view, click on the Detail View icon in the drawing toolbar, or find the Detail View command in the drop-down menu under Insert, Drawing View, Detail. The command automatically activates the Circle Sketch tool. With the Sketch tool, draw a circle to identify the area that you wish to zoom into. Once the circle has been sketched, move the pointer to the area on the sheet where you wish to locate the view and click once. The detail view will appear with a label. The label and font can be customized here in the Property Manager. There are also options in this drop-down list that allow you to select different display options for the view. Notice that the view appeared with a custom scale of 2:1. This automatic scaling happens as a result of a setting found under System Options in the Drawing section. Here you see the default scale I'm using is 2x, or twice the overall sheet scale. Even after the detail view has been created, the area covered by the detail view can be changed at any time. To increase the area of the detail view, click on the circle used to create the view and drag the circumference of the circle. To move the circle, click and drag the center. As you do this, notice that the detail view will update immediately to show you the result. A broken view can be used to take a view like this, which is too large to fit on your drawing sheet, and break it so only important details are shown. To break a view, select the break icon in the View Layout toolbar. Select the type of break in the Property Manager and the desired gap size and break line style. Next, simply move your cursor to the area of the view where you would like to start the break. Click once to locate the beginning of the break, then click again to locate the end of the break, and the view is automatically broken. Any dimensions spanning the break will still display the true dimensional value. However, the dimension line will have a visual indicator that it is dimensioning a broken view. To create additional breaks, simply repeat the process while the command is still active. To make any changes to the break properties after it has been created, select or right-click the break lines and make changes in the Property Manager or from the right-click menu. Any drawing view of an assembly can be displayed in an exploded state, as long as the assembly already has an exploded view defined. Here, for instance, I have an isometric view of this assembly. If I wish to show this in its exploded state, I simply right-click on it, select Properties, and right here you see the option to show an exploded state. As soon as I click OK, you see the view update. Another option you have with any assembly view is to hide components. All I have to do is right-click and select Properties again, and here you see the Hide Show Components tab. Any components listed in this window will be hidden. To add components to the list, you just click on them in the graphics window, and when you click OK, the component is hidden. To show the component again, repeat the process and take the component off the list by selecting its name and pressing Delete on the keyboard. When working with parts or assemblies, you can control the way a model is displayed using the Display Style flyout menu from the Heads Up toolbar. These same display options are available when working with drawings. However, notice that by default the icon is grayed out. In order to activate the icons, I first have to select a view. This is because each view can be displayed differently. For example, I can display the isometric view as shaded, the front view and hidden lines visible, and leave the rest as they are. If you want to change several views at once, you can Control-select them, then choose the display type you want. If you find yourself constantly changing the way your views are displayed, you may find it useful to change the default appearance of all new views you create. This is a setting under Options, Display Style. Save some time by setting this option to the display type you use most often. Note that this setting does not affect views already in place. It will only affect new views you create in the future. There are several types of views that are automatically aligned to a parent view when they are created. These include section views, auxiliary views, and projected views. In this case, I have a section view that I want to move down below the parent view. As I drag the view, you can see it is aligned so that it can only move side to side. I can break this alignment by right-clicking on the section view, selecting Alignment, and Break Alignment. Now the view can be dragged anywhere on the sheet. Should you ever need to realign the view, you can right-click to access the alignment option again and simply select one of the alignment settings, or default alignment to return to the original setting. When working with SolidWorks drawings, the scale of drawing views can be controlled at two levels. You can change the scale of the entire sheet, or you can change the scale of individual views. To change the scale of the entire sheet, right-click Sheet 1 here on the Feature Manager tree and select Properties. I can also access sheet properties by right-clicking anywhere on the sheet in the graphics window. Selecting Sheet Properties will cause this window to appear. You see that among several other properties, including the size of the sheet and the type of sheet format I'm using, I have access to the sheet scale. I'll make a change here and click OK. As soon as I do, you can see that every view on the sheet is now changed. If, on the other hand, you only want to change the scale of one view, simply click on the view to activate it, and in the Property Manager, you will see the Custom Scale option. I'll activate it by selecting the checkbox. Type in a new value and click the green check to accept the change. Something to keep in mind is that this view is now set to use a custom scale, so when you make a change to the sheet scale, this view will not be affected. To return the view back to the sheet scale, simply click on the view and check Use Sheet Scale in the Property Manager. Probably the most important element of detailing a drawing is displaying a part or assembly's dimension. When dimensioning a detailed drawing in SolidWorks, it's important to know the two types of dimensions you can use in drawings: driving dimensions and driven dimensions. Here we see examples of both. Although they might look similar, there are some vital differences that differentiate the two. First, let's look at driving dimensions. These dimensions will appear black by default. The color is not important in any way except that it helps us identify them from driven dimensions, which appear gray. Driving dimensions control the geometry they are attached to. They drive the model. For instance, if I double-click this dimension of 2 inches, a spin box comes up and I have the ability to change the dimensional value. When I change the dimension to 1 inch and rebuild, you can see the model change. If I change it back to 2, the model changes once again. So you see that a driving dimension is no different than the dimensions you would use to create this part in 3D. In fact, that's exactly where these dimensions come from. They are directly imported from the 3D model, whether it be a part or an assembly. Because they can be easily imported, driving dimensions are used primarily to save time when detailing a drawing. Now let's look at driven dimensions. As I mentioned, driven dimensions will appear gray by default, so you can tell them apart from driving dimensions. Driven dimensions are for reference only. They're there to tell me the length of an object, but their value cannot be changed to drive the model. If I attempt to double-click a driven dimension, I don't see a spin box where I can change its value. Instead, I only see the dimensions Property Manager. Instead of being imported from the 3D model, driven dimensions like these are added manually using the Dimension tool. While this may seem like a redundant process, driven dimensions offer you more control in how you want your drawing dimensions to appear. In the following sections, we'll learn how to create dimensions and take a close look at the options that are available with each type. This will help you decide which type of dimension, driving or driven, best suits your needs. The 3D model, when it was created, has dimensions that were added in sketches and features to determine the part's size and shape. As we saw in a previous lesson, I had the option to mark dimensions for drawings on this button here while creating the part. One method of dimensioning a drawing is to import these dimensions from the 3D model. These dimensions, once they're imported into the drawing, are driving dimension. As we learn, this means that they can be changed in the drawing and reflect the changes back to the model. So how do we import these dimensions from the model into the drawing? Well, to do this, select Model Items. Here in the Property Manager, you can select the types of dimensions, annotations, or reference geometry that can be brought over from the 3D model. In this case, I'll only select dimensions that were marked for the drawing to import. Here are options which help control the appearance of the dimensions that will be imported. The first allows me to specify whether dimensions should be imported into all drawing views on the sheet. If I only want to bring dimensions in for one view, I can clear this checkbox and select which view the dimensions will appear. I can select one or more views in this window, and only those listed will be considered when importing dimensions. In this case, I'll import dimensions into all views. The next option controls whether dimensions of items that are completely hidden will be imported. By default, this checkbox is cleared, and for most applications, you'll want to leave it that way. As soon as I click OK, all dimensions that were marked for the drawing will be brought over from the model. You can see how quickly a drawing can be dimensioned this way. But also notice it's a bit messy and difficult to read. This can be fixed by moving dimensions and changing their appearance. To move a dimension, you simply click on it and drag it around the screen. Notice that when I click on a dimension, it becomes highlighted, and here in the Property Manager, I can see the properties that correspond to it. I can use these properties to change the precision of the dimension, or to add a tolerance if necessary, or a number of other options specific to this dimension's appearance. I can also use these dots to change the direction of the arrows. If I right-click the dimension, you'll see there are display options. These allow me to do things like center the text between witness lines or display the text within parentheses. One more option that may be useful is here at the bottom of the Property Manager. It's here in these fields where I can add notes to a dimension. For example, typical or 4 times to specify a quantity. If you want to move a dimension from one drawing view to another, you can do this by holding down the Shift key while dragging it to another drawing view, and the dimension will be moved. Another option is to copy the dimension or any other type of annotation from one drawing view to another by holding down the Control key. The cursor will give you feedback if a move or copy from one drawing view to another is possible or not. If you need to get rid of a dimension, just click on it and press Delete on your keyboard. Note that although these are driving dimensions, deleting them from the drawing will not affect the 3D model. In this section, we'll take a look at the many options available when using driven dimensions in drawings. While driven dimensions can take more time to create than inserting dimensions from the 3D model, many users prefer them because their appearance and location can be controlled more precisely as they're created. Driven dimensions are created just like dimensions you would use to define a sketch. You simply click on the dimension icon and select the entities you wish to dimension. After I click on the segment, a manipulator appears which lets you create rapid dimensions. This manipulator is convenient because each dimension will be automatically positioned and spaced evenly apart. To create rapid dimensions, I hover by pointer over the circular manipulator to see a preview of the dimension. To move the dimension to the other side of the part, I can move my mouse to the side of the manipulator or press the Tab key. However, if I move the cursor away from the manipulator, it disappears, and I can manually place the dimension anywhere on the drawing. I'll click on another line to dimension. To place the dimension, I can either click on the manipulator or press the space bar. I'll continue to add more dimensions, and you can see that the manipulator will space them evenly with the last dimension I placed. The manipulator is slightly different when dimensioning circles or by clicking on 2 points that are not horizontal or vertical to each other. If I dimension a circle, I have 4 choices for placing the dimension. If I click on 2 points that are not horizontal or vertical to each other, I'm also given 4 choices. The left and right options will dimension the vertical distance, and the top and bottom will dimension the horizontal distance. However, if I wanted to dimension the angled face, I have to click on the line to get the overall dimension. Once these dimensions are in place, you can highlight them and move them or change the direction of their arrows. This works the same as with driving dimensions. I can even add tolerances and customize other aspects of the dimension if necessary right here in the Property Manager. I can also quickly change the tolerances and formatting of the dimensions by using a flyout window called the Dimension Palette. I can show the Dimension Palette by clicking on a dimension, and I can hover over it to show it completely. This is where I can adjust the tolerance, precision, and formatting. If I make changes using the Dimension Palette, the formatting is saved in the Styles or Star icon drop-down. I can select another dimension and apply the same formatting by clicking on the star icon, then select the format. You can see that by manually adding these dimensions, I control how this drawing will appear. If I were to insert dimensions directly from the 3D part, I would be giving up this control to SolidWorks, and I'd have to go back and clean up the imported dimensions. In addition to placing regular dimensions as I'm doing here, the Dimension tool gives me access to special types of driven dimensions. For instance, I can create ordinate dimensions, baseline dimensions, and others. Don't worry that driven dimensions show up as gray. This helps tell them apart from driving dimensions. If you wish to make sure they appear black when you print, set your printer settings to print in black and white. Ordinate dimensions are a type of driven dimension. To create them, use the Dimension drop-down icon and select Ordinate Dimension. If you want to specify the direction of the ordinate, you can choose horizontal or vertical. In this example, I'll simply pick Ordinate Dimension, and I'll click on this lower edge to define the ordinate, or zero reference. With the first click, I located the ordinate, and now every point or edge I select will automatically be added to a group of ordinate dimensions. Once I'm finished adding to the group of ordinate dimensions, I can click the Dimension tool again to complete the group. One more click and the icon is turned off altogether. Ordinate dimensions behave as a group. For example, if one of the dimensions is moved, the entire group will move along with it. If you wish to go back and add to the group, you must right-click one of the dimensions and again select More Dimensions, Ordinate. Another type of driven dimension that can be useful is a baseline dimension. To create baseline dimensions, click on the Dimension drop-down icon and select Baseline Dimension. And now you can pick a point or line to establish the first dimension. This dimension seems just like any other, but as you continue to pick other geometry, the following dimensions will be automatically placed using a common baseline. If you select one of the baseline dimensions and move it left or right, you can see they all move as a group. If you wish to change the spacing between them, you actually have to change a setting in the options of this document. Here in Document Properties is a list of categories, including dimensions. This is where the spacing of baseline dimensions can be modified. I want to spread out the dimensions, so I'll change these values to something a bit larger. You can now see the dimensions become more spread out and much easier to read. When you create drawings of parts that include holes, you'll likely want to use center marks to help locate the holes. As I begin a new drawing of this plate, I want to show you an option that will affect the appearance of center marks in your drawings. You can see here I have the option of having center marks automatically added to holes and/or fillets in my drawing as soon as a view is created. Let's leave this option on and take a look at what happens. I'll go ahead and insert a front view of this part. And with that option turned on, all of the center marks are added automatically based on my setting. Let me delete this view and turn off the center mark options. Now when I recreate the view, the center marks are left off completely. To manually add the center marks I want, I simply click on the center mark icon from the Annotations toolbar and pick the edges that I wish to mark. Center marks will be automatically sized to fit a hole, so be sure that if you have more than one edge to select, like with this counterbored hole here, always pick the outermost edge. Another very useful annotation is the hole callout, which automatically annotates different types of holes. This is the hole callout icon. Once it's activated, you simply click the edge of a hole. Click again to locate the callout, and it's done. You can repeat the process for each hole. Here in the Property Manager, you can change the appearance of the callout, such as its justification, or if you need to modify the text of the callout, you can type it in right here. Notes are an essential element in creating drawings. In this section, we'll take a look at how to create notes and how to control their appearance. Notes are created by using the Note command found in the Insert drop-down menu under Annotations. A note icon is also present in the Annotations toolbar. Once the command is active, you'll see the Property Manager change to show the options that will control the appearance of the note. These options include several types of leaders and arrows, text justification, note font, and borders. Next to the pointer, you will see a box. This box is prompting you to click somewhere on the sheet to begin typing. As I move the pointer, notice that when I hover over the model, a leader will appear attaching the note to the part. The option responsible for this behavior is this one here, called Auto Leader. If I were to select the leader option, a leader would always be displayed regardless of where I locate the note. Likewise, the No Leader option eliminates the leader regardless of the note location. I'll keep the Auto Leader option on for this example. As soon as you click on the drawing sheet to locate a note, the formatting toolbar will automatically appear. You can use it to change font type, size, and style. You can also change the text color and justification. Just like you might be accustomed to in word processing programs, you can format specific characters by selecting them and choosing different formatting options. This also allows you to create notes with multiple lines and bulleted lists. Once you're finished with the note, you have a couple of options. You can complete the note and exit the Note command by clicking the green check in either corner. Or if you wish to continue creating additional notes, simply click anywhere else on the sheet. This will finish the current note, but the Note command will remain active, so you can go on to the next note by clicking again. Notice that the same text is automatically repeated. This can be useful at times, but if you need to type something different, go right ahead. The new text will overwrite the existing text. Once your notes are in place, you can control their alignment using two different methods. The first method is to dynamically change the note alignment by dragging the note. Notice as I move my cursor along the bottom of the note, the cursor icon changes. When I select the note near its left edge and drag it, it will try to snap to the left of any other notes. By selecting the middle of the note will snap to the middle of any existing notes, and so on. The second method is to select the notes that you wish to align, by either control selecting them or by using a window selection, then right-click on one of the selected notes. In the menu that appears, select Align, then the option you wish to use. Here I'll pick Align Left. These alignment capabilities are not just limited to text notes. They can also be used with dimensions and balloons. With notes, you can also control how the leader lines are attached. Here I have a note with multiple lines. The options in the Property Manager control how the leader is attached. They can be attached to the top, bottom, center, or nearest part of the note. One more important item regarding notes has to do with Dynamic Drawing View activation. Because of Dynamic Drawing View activation, these notes are associated with this view. When I move the view, the notes will move with it. If you do not wish for notes to be tied to any particular view, use the Lock Sheet Focus option. For more on this, review the section on Dynamic Drawing View activation. You will find further information regarding notes in the section entitled Creating Custom Sheet Formats. See this section to learn how to create smart notes that update automatically to display typical information such as material scale, author, and so on. Creating an assembly drawing is very similar to creating a part drawing. Starting a new drawing, selecting a sheet format, and creating drawing views. All of this is done exactly the same as with part drawings. There are a few things, however, that are unique to assembly drawings. One of them is the ability to create a bill of materials, or BOM. A BOM is a parts list. It identifies the different components in an assembly. Generating a BOM in SolidWorks is easy. First, you have a view of the assembly. Now here I have an isometric view, but any view will work just fine. Next, you have to select the drawing view of the assembly so it's activated. Once the view is activated, you can bring in the BOM using the Insert Tables drop-down menu and selecting Bill of Materials. Next, this window will prompt you to select from several options to create the BOM. Eventually, you may want to customize a template to conform to your company standards, but for now, I'll select the generic template as you see it. You can select the option for top-level parts only, include parts from subassemblies, or make the BOM specific for any configuration you may have already set up. Don't worry, if you miss any of these options, they can be modified after the BOM is placed on the sheet. I'll accept the defaults at this point and click OK to generate the BOM. Notice I can click and drag the BOM anywhere on the sheet. If you don't want it to be free to move, you can use an anchor point to lock it down. To do this, first you must establish an anchor point on your sheet format. Right-click on a blank area of the sheet and select Edit Sheet Format. This will isolate the lines and notes that belong to your title block. Any point or endpoint of a line can be used as an anchor. To set the anchor, right-click a point and select Set as Anchor. Bill of Materials. Once this is done, we can exit Sheet Format mode and return to Edit Sheet mode. Remember to return to Edit Sheet mode, right-click a blank area of the sheet, and select Edit Sheet. Now that I've established an anchor point, I can return to the properties of the BOM to attach it to the anchor point. Select the BOM table to bring up the properties. Be sure you have the entire table selected by clicking here at the top. Here you see the option to use an anchor point. I'll select this option, and now we can decide which corner of the BOM will be tied to the anchor point. In this case, I'll select the top left corner and click OK. As you can see, the table is anchored. It's no longer free to move. Let's take a look at another BOM option that's important when dealing with assemblies containing subassemblies. This assembly here is made up of 3 parts, but 2 of them are in a subassembly. The way the parts are listed in the BOM, you can't tell that a subassembly exists in this assembly. There's an option in the BOM properties that can change the appearance of the subassembly. Here in the middle, I can choose to display the subassembly as if it was a part. Or I can choose to display the subassembly with its parts indented. SolidWorks lets you customize your BOM tables with almost unlimited flexibility. I'd like to show you a few common ways to do this. Here, I have a drawing with the BOM table already added. To get started, I can edit the structure of the table by using the Assembly Structure column of the Bill of Materials. To view the Assembly Structure column, click on the arrows on the left side of the BOM. If I right-click on one of the icons, you can see I have the option to exclude the component from the BOM. When I click on it, a window asks me to confirm that I will be removing the component. I'll click OK, and the component is removed. To return it, browse for the component in the feature tree, right-click on it, and select Include in BOM. If I again right-click on a component in the Assembly Structure column, you'll see another new option called Component Options. When I click on it, a pop-up window appears with a couple options. The first option allows me to change the name of the component in the BOM. I can have it set as the document name, the configuration name, or set it to user-defined to enter a different name. Since this is a subassembly, I get a section called Child Component next. If this was a single component, this section wouldn't be visible. Here I can show or hide the subassembly or select Promote to dissolve the subassembly and to view each component by itself in the BOM. Now I can click the green check, and since I had Promote selected, I'll get a message window to confirm that I'll be dissolving the assembly in the BOM. I'll click OK. As you can see, the subassembly is no longer visible, but each of its components is now listed individually. The next section edits how the quantity is calculated. If you have an item that you need included in the BOM, but that doesn't have an exact quantity in the assembly, such as an epoxy, lubricant, or length of a wire, for example, you can edit how the quantity is displayed here. However, you must first have a custom property created for the part. If you don't have any custom properties created for the part, the only option here is None. The drop-down here lets you select any of the custom properties you've created to be displayed in the quantity section of the BOM. It's important to note that you can have SolidWorks automatically link any custom properties that you have defined to the bill of materials, such as the description as well. While I'm on the subject of visibility, when selecting parts in the assembly structure column, notice the component or subassembly will highlight in the drawing. Also, selecting a component in the feature tree will highlight it in the BOM. If I hover my cursor over the icons in the assembly structure column, a thumbnail preview of the component is shown. Bill of materials can also now be moved between sheets in a drawing. To do this, use the Move icon in the upper left-hand corner to drag the BOM over a different sheet tab at the bottom. You'll see the cursor change to an arrow, and releasing the mouse button will move the BOM. I can also drag and drop a BOM onto a sheet in the feature tree to move it. Just click, drag, and drop over a sheet name. There are a couple more new things I'd like to show you in working with BOMs. Let me switch over to a different design. Here I have a simple assembly with the bill of materials already created at the assembly level. I also have a drawing already created for this assembly. I'll open the drawing and go to Insert, Table, Bill of Materials. I'll choose the assembly view on the drawing sheet. Notice in the Property Manager, I have the option to create a new table or to copy an existing table. I'll choose to copy the assembly BOM. When I do, SolidWorks also displays a checkbox asking me if I'd like this table to be linked to the assembly BOM. If you choose to link your bill of materials, all the data from the assembly BOM will be parametrically linked to the BOM in the drawing. Now you can still format the tables independently, such as the font size, color, height, width, but the data included in the table will be linked. I'll make this a linked table. Click the check and click once more to place the table in the graphics area. If you decide later on that you want to unlink the BOM, simply click the upper left corner to select the entire table and bring up the Property Manager again. You can then uncheck the Link checkbox to unlink the table. One important thing to remember, if you unlink a BOM, you cannot reestablish the link. You have to create a whole new table if you want the link back. There are a couple more things I'd like to show you when working with BOMs. In the assembly section of this course, I mentioned how bills of material can be created in both the assembly file as well as the drawing file. If you find yourself using BOMs in the assembly file, I'd like to show you how you can leverage the work you might have already done in the 3D assembly and use it in a 2D drawing. Now, just as a refresher, the process of adding a BOM in an assembly is almost the same as I would if this were a drawing, by going to Insert, Table, Bill of Materials. Here I have a drawing already created for this assembly. If I want to reuse the same bill of materials table that was used in the assembly file, I can go to Insert, Table, Bill of Materials. I'll choose the assembly view on the drawing sheet to tell SolidWorks which file the BOM should be associated with. Notice in the Property Manager, I have the option to create a new table or to copy an existing table. I'll choose to copy the assembly BOM. When I do, SolidWorks also displays a checkbox asking me if I'd like this table to be linked to the assembly BOM. If you choose to link your bill of materials, all the data from the assembly BOM will be parametrically linked to the BOM in the drawing. Now you can still format the tables independently, such as the font size, color, height, and width, but the data included in the table will be linked. I'll make this a linked table. Click the check and click once more to place the table in the graphics area. If you decide later on that you want to unlink the BOM, simply click the upper left corner to select the entire table and bring up the Property Manager again. You can then uncheck the Link checkbox and click the green check to unlink the table. One important thing to remember, If you unlink a BOM, you cannot reestablish the link. But just as you saw a moment ago, it's a simple process to reinsert the BOM from the assembly file if you want the link back. There's one last thing I'll mention about the assembly BOM here. If you want control of what fields are listed in the table, this is from a setting found in the BOM properties of the assembly. Let me show you. I'll reopen the assembly. Switch over to the Configuration Manager. I'll right-click on the default configuration and select Properties. This brings up the properties for this configuration. If I activate the Use in Bill of Materials checkbox, the properties here will automatically be used in the Bill of Materials. Once the BOM is in place, balloons can be used to tie the information in the table to the parts in the assembly view. Because balloons are a type of annotation, you can use Insert, Annotation, Balloon from the drop-down menu, or the balloon icon on the Annotations toolbar. Once the command is selected, your pointer will show a small picture of a balloon next to it. All you do now is click on the parts in the drawing view, and balloons will appear with the appropriate item number. If you pick on a face, the leader will attach with a dot. If you pick an edge or a vertex, the leader will attach with an arrow. Once the balloons are in place, click OK and position the balloons as you please. When a balloon is highlighted, the Property Manager appears, allowing me to change the size and shape of the balloon. In the Style section, I can load a previously saved balloon style or add a new style to use in future drawings. The Balloon Settings section is where the appearance of the balloon is determined. I can change the shape of the balloon and the size. Notice there is a user-defined option allowing me to numerically specify the size. I can also change the content of the balloon. Finally, there is a quantity section. Once I click on the check, a quantity value is placed next to the balloon. This quantity is parametrically connected to the part, which eliminates the need to create a separate note. You can also let SolidWorks create all of the balloons for you using the Auto Balloon command. I'll highlight the view to make it active, and select Auto Balloon from the Insert, Annotations drop-down menu, or select the Auto Balloon icon. Here you can select the orientation in which the balloons will appear around the view. For this example, I'll select Top and click OK. Just as we saw a second ago, I can still position the balloons anywhere by dragging them. One important thing to point out here: if you wish to reposition all the balloons together as one unit, you must do this before hitting the check to accept the auto balloon. Moving a balloon after completing the command will only allow you to move the single balloon and not all of them as a group anymore. There are many options that affect the appearance of a detailed drawing: dimensioning standard, units, note font, arrow size, and the list goes on. You can take the time to adjust these options in the drawing options setting, but it would be nice to be able to save them so you don't have to repeat the process each time you begin a new drawing. This can be accomplished by creating custom drawing templates. To create a custom drawing template, begin by starting a new drawing file. If you select a sheet format or title block here, it will be saved into your drawing template. For instance, if I select an E-Landscape format, every time I use the custom template, it will have an E-Landscape title block. If you don't want to be tied to any particular title block, select No Sheet Format here. Now, let's make some changes to the settings that will affect this drawing. In Options, notice that all settings are divided into two tabs: System Options and Document Properties. All changes made in the Document Properties tab will be stored in the custom template you create. For this template, I'll select ISO Standard. I'll change my note font to 24. And I'll change my units to centimeters with 3 decimal places. Once these options are set, it's time to save this template. From the File drop-down menu, select Save As. Change the Save As type option to Drawing Templates. The directory you are saving in will automatically change to a default folder where SolidWorks stores its templates. You can save your template here, or you can browse to a completely different folder on your local hard drive or on a network if you prefer. If you choose to save to a folder other than the default, there is a special step that you must perform to be able to access your custom template. I'll go over this step at the end. For now, I'll give my custom template a name and click Save. Now that the custom template is saved, when I begin a new file, you can see it as one of the templates I can start with. And I don't have to worry about changing all my settings every time. I mentioned earlier that if you choose to save your custom templates into a folder other than the SolidWorks default, there's an additional step that you must perform. Let me save this template into a different directory. If I begin a new file at this point, notice that the template I just saved does not appear on the list. To make it visible, I have to tell SolidWorks where I saved it. In Options, there's a section called File Locations. This allows me to tell SolidWorks where to find certain types of files, in this case, document templates. Click the Add button, browse to the folder that contains your custom templates, and click OK. You can see the folder is added to the list. Now when I begin a new file, you can see the new folder appears as a tab right up here, and the custom template can now be selected. Sheet formats used in drawings can be customized to comply with your company standards and saved for later use. Typically, a custom sheet format begins as one of the generic sheet formats supplied with SolidWorks, and changed to include company logos, special notes, and any other information that you wish to include in your drawings. Custom sheet formats can also be imported from other CAD applications or extracted from existing SolidWorks drawings. In this example, I'll show you how to take a generic sheet format and add custom notes to make it your own. I'll begin by starting a new drawing with a B-landscape sheet format. Since we're only concerned with the sheet format and not the rest of the drawing, I'll switch to Edit Sheet Format mode. If you need clarification on the difference between Edit Sheet and Edit Sheet Format mode, see the section entitled Introduction to Drawings. Take a look at the notes here in the corner. There are two types of notes here. These standard notes, which are nothing more than text, and these smart notes. Smart notes allow you to display information about a file instead of typing it in each time. For instance, here under Material, instead of typing in steel, a smart note is used to display the material of the model contained in the drawing. If this was not a smart note, when I used a model made of plastic, I would have to manually edit this note to read plastic and not steel. In an earlier lesson, we covered how to create standard notes. Here I'll show you how to create a smart note. Use the Note tool, just as you would with a standard note, and click the location of the note. Instead of typing in text, click on this button to link this note to a file property. Since we're linking to a file property, you can choose whether you want to link to the current file, which is the drawing file we are working on, or a model shown in a view. This would be a part or assembly that would eventually be displayed in this drawing. For this example, I'll use Current Document and select a property from the list. In this case, the author of this drawing. Adjustments can be made to justification and font as needed. The sheet format includes notes, but also the title block fields. These fields are created with lines just like a sketch, so they're easy to modify. In this sheet format, I'll get rid of the revision block up here in the corner. I'll select the line segments and hit delete to get rid of the line segments and the notes altogether. Now that I've made some changes to my sheet format, I'll go ahead and save it. In the File drop-down menu, you'll find Save Sheet Format. I have two options. I can overwrite the standard B-landscape sheet format, or I can create a new custom sheet format and leave the original B-landscape unchanged. I'll select the custom option to create a new one. Now when I create a new drawing, I can select the custom sheet format option and browse to my newly created sheet format to start with. This concludes the section on drawings in SolidWorks. If you feel unclear on any of the sections presented, feel free to review any specific category from the menu.